Hello, Matthews Gatos here. Welcome to Implicit Differentiation. So far, everything we've been doing has been explicit functions, which are just functions where one variable can be expressed explicitly in terms of another. So these are all those y equal equations, or they can be written as y equals equations. So some examples would be y equals x squared, y equals the root of 4x squared over x plus 1, etc. So y equals everything in terms of x. So let's write this function, x squared plus y squared equals 25 explicitly in terms of x, and then let's find its derivative. So we want to find its derivative so we can find the slope of the tangent line at -3, -4. So first things first, let's write the explicit function. So I'm going to get y by itself. So I have y squared equals 25 minus x squared, subtract x squared from both sides, and then take the square root. Now remember, when I take the square root, it's always going to be plus or minus. So I have y equals to positive the root of 25 minus x squared, and y equals to negative the root 25 minus x squared. So here on the top half, this top half here is the y equals positive root, and on the bottom here, that's the y equals negative root. So because -3 and 4 is in the bottom half, I am going to use this equation only, and I'm going to find the derivative of that. So let's write this as an exponent instead of a root. So let's write this as y equals to negative 25 minus x squared to the 1/2. Then when I want to take the derivative of that, I'm just going to bring the half down, so it'll be -1/2. 25 minus x squared, decrease my power by 1, and then derivative of the inside, which is -2x. Now I'm only trying to find the slope, and I have a specific point, so I don't need to simplify any further than that. I can just plug my values in. So y prime, which is the slope, is -1/2 25 minus x squared, and I see that x is equal to -3. So that's going to be -3 squared to the -1/2 times -2 times -3. So let's tidy this up. So I have y prime is equal to -1/2. So -3 squared, -3 times -3 is 9. 25 minus 9 is 16 to the -1/2, and then multiplied by +6. So let's continue simplifying this. So I have -1/2 of 6. -1/2 of 6 is -3. And then 16 to the 1/2 is the square root of 16, which is just 4. So that means the slope of the tangent line at -3, 4 is -3/4. So what we're going to do is we're going to take this same question, now that we know the answer, and we're going to solve it implicitly. So what is implicit? Well, an implicit function is a function where the variables have a relationship between them. So the x and the y are connected, just like that last question that we saw. Now I could write it explicitly, but I could also leave it implicitly. So implicit differentiation is just a special case of the chain rule. What you're going to do is take the derivative of both sides with respect for x, and then solve for dy by dx or y prime. So taking the derivative of both sides with respect to x. For example, if I have x squared, well, the derivative with respect to x is just bring the exponent down 2x, and since it's only just x, the derivative of x is 1. So I just multiply it by the 1, and it just becomes 2x. Now, if I take the derivative of y squared with respect to x, I bring the 2 down, and it's going to be 2y times dy by dx, which is just the derivative of y with respect to x. So what we're going to do then is multiply dy by dx, or y prime, and it becomes the derivative of y with respect to x. Let's do an example. We're going to do that same example, but we're going to do it with implicit differentiation. So I'm going to take the derivative of both sides with respect to x. So x squared plus y squared, equals to 25. Let me try that again. Okay, equals 25. So take the derivative of both sides with respect to x. So this will be 2x plus 2y y prime equals 0. Now, I was given the point -3 and -4, and you saw when we did it explicitly, I only needed my x value. But now that I have y values, I can substitute that in as well. So substitute in x for -3 and y for -4. And then we want to isolate for y prime, which is in fact the slope. So I have -6 minus 8y prime equals 0. Let's add 8y prime to both sides, and then divide both sides by 8. And so you get y prime, which is the slope, is -6 over 8, or in lowest terms, -3 over 4. And you see I get the same value. But I think that might be a little simpler. So once we take our derivative, sub in the point, find the slope. You don't need to simplify first because I'm looking for a numeric value. So let's try that again. For the curve given, find the slope of the tangent at 1 and 2. So again, this is an example where we're just finding the slope, which is a number, and we're given a point. So we don't need to fully simplify. Okay, so there's my function, and I'm doing the derivative with respect to x. So on this side here, 5 comes down, multiplied by the 10, decrease your power by 1, plus, now we have a product. So we're going to use product rule. So I do that as 1 d2 plus 2 d1. The 4 comes down, 4x cubed, plus y exponent 5. That's just power law, so bring the 5 down, decrease it by 1. But because it's not an x, I'm going to do this with respect to x, so it will be y prime equals the derivative of a constant is just 0. So let's tidy this up. Actually, we don't need to tidy it up. I changed my mind. Let's just plug in x and let's plug in y and figure out what y prime is, which is the slope. So I'm going to have 10x exponent 4 plus x exponent 4 times y prime, which we're going to solve for, plus y times 4x cubed, 1 cubed, plus 5y exponent 4 y prime equals 0. So this is just 10 plus y prime plus 2 times 4 is 8, because 1 cubed is just 1, plus 2 exponent 4 is 4, 8, 16. 16 times 5, 80. Y prime equals 0. So group our y primes together. We have 81 y prime equals 10 and 8 is 18, but I subtract it from both sides to get -18. So simplifying this, I'm going to have y prime equals -18 over 81, which in lowest terms, divide each by 9, becomes -2 over 9. So that means the slope of the tangent line is -2, 9 at the point 1 and 2. Okay, in this example here, we're going to do it in general, so a factored expression for y prime. So same process, except we're not plugging in numbers. So we're doing it in general. So x cubed y squared plus y equals 5x squared. So I'm just going to leave it as it is because there's nothing for me to simplify. And just take the derivative of both sides with respect to x. So this is product rule here. So I'm going to do 1 d2, so the 2 comes down, times y prime, plus 2y squared d1, which is 3x squared. So that's 1d2 plus 2d1. Let's just move this over. And then plus the derivative of y with respect to x is y prime, equals on the other side, bring the 2 down and multiply it by the 5, decrease your power by 1. So I want to get anything that has a y prime on one side of the equation and anything that doesn't have a y prime on the other. So I'll write this as 2x cubed y prime plus y prime equals, Now I have the 10x over there, but I want to multiply these two together and subtract it. So I'm going to subtract the product 3x squared y squared. Okay, on the left-hand side, I'm going to factor out a y prime. In doing so, I'm left with 2x cubed y plus 1 equals 10x minus 3x squared y squared. So now to solve for y prime, I can just divide by what I've multiplied it by, which is 2x cubed y plus 1, and I do that to both sides to be fair. So that's gone. So y prime is equal to 10x minus 3x squared y squared all over 2x cubed y plus 1. So I notice in the numerator I have a greatest common factor of x, so I can take that out, and I'm left with 10 minus 3x y squared all over, nothing to do in the denominator, so I'll leave it as is, and that would be your first derivative. Okay, let's try another one here. So determine a factored expression for y prime for the following. So again, I have 3y squared. I'll just write my function out again. And then I'm going to take the derivative of both sides with respect to x. So 3y squared, if I take the derivative of that, the 2 comes down multiplied by the 3, decrease my power by 1, y prime. Minus. Now I have product rule, so I got to be super careful when I'm subtracting. I'm going to put this in brackets. So I'm going to do 1 d2 plus 2 d1, all in brackets, plus derivative of x equals derivative of y, and derivative of negative 8 is 0. So let's get rid of those brackets. So I have 6y y prime minus 4x y prime minus 4y plus 1 equals y prime. So again, I want to get anything that has a y prime on one side, anything that doesn't on the other. So I will leave negative 4 plus 1, negative 4y plus 1 on that side. And I will subtract 6y y prime and add 4x y prime to both sides. So on the left side, I'll leave it alone. On the right side, I will factor out a y prime. Okay, so dividing both sides by what I multiplied y prime by. I've got 1 minus 6y plus 4x. Cancel that out. And then I have, I'll put my y prime first here. Y prime is negative 4y plus 1 divided by 1 minus 6x plus 4x. 6y, sorry, plus 4x. So this altogether is my first derivative. Okay, let's look at this one here. So I have x squared plus, I'm going to write that as y to the 1/2 equals x squared y cubed plus 5. So again, I'm taking the derivative of both sides with respect to x. So 2x, the 2 comes down, the derivative of x squared, plus the 1/2 comes down, decrease your power by 1, multiply by y prime because it's with respect to x. Okay, again, I have a product here, so I do 1 d2 and then plus 2 d1, and the derivative of 5 is just 0. Okay, so again, I want to get anything that has a y prime on one side, anything that doesn't have a y prime on the other. So I'm going to keep my 2x here, and I'm going to subtract my product of y cubed 2x, but I'll write it as 2xy cubed. Okay, that is equal to, on the other side, I have 3x squared y prime, and I will subtract half y to the negative half y prime from both sides. So everything with a y prime is on my right side. So I have 2x minus 2xy cubed equals, on this side factoring out a y prime, I have 3x squared y squared minus 1/2 y to the negative 1/2. So I'm actually, now that I'm noticing that, going to factor out more because I do have a greatest common factor, but I'll do that after I divide. So I want to get my y prime by itself first. So 3x squared y squared minus 1/2 y to the negative 1. We're going to divide both sides by that, and then I'll tidy it up. So 3x squared y squared minus 1/2 y to the negative 1/2. Okay, so that's gone. So I just got a bit of work here to do. So in the numerator, I notice I have a GCF of 2x. So taking that out, I'm left with 1 minus y cubed over. In the denominator, I'm going to take out a 1/2. Remember, I don't want fractions in my factors. And I'll take out a y to the negative 1/2, always the smaller exponent. So I'm left with 3 divided by 1/2, which is 6, x squared, and then y squared divided by y to the negative 1/2. So keep your base the same, subtract your exponents. So 2 take away a negative 1/2 is like adding 1/2. So that's 2.5, or I'll write it as 5/2. And then minus the half cancels and the y to the negative 1/2 cancels, you're just left with 1. Okay, so tidying it up a little bit more here, I have 2 divided by 1/2, which is really 4x. Y to the negative 1/2, I'm going to put that in the numerator as a square root of y, multiplied by 1 minus y cubed, all over 6x exponent 2, the square root of y exponent 5 minus 1. And that will equal to my first derivative. So you know that expression going off on a tangent? Well, you can understand this now because of calculus. It's called going off on a tangent because a tangent is a derivative of the original conversation. So I hope this video helped, and I look forward to seeing you for the next one.